What is data science? To put it simply, data science is the practice of using data to answer questions and make better decisions. Of course, it's more involved than that, but that is the direct answer to a direct question. But let's understand what it is with an example. Imagine you own a small coffee shop. You track how many customers come in, what they buy, and at what time. Data science helps you look at that information and discover patterns. For example, it may help you discover that lattes sell more than any other drink, or that Fridays are the busiest days of the week, or maybe the incredible amount of cappuccinos sold before noon, especially if your shop happens to be in Italy. Basically, it's what allows you to take raw information and turn it into useful insights. To give you the more formal definition, data science is an interdisciplinary field that uses statistical methods, algorithms, and computer systems to collect, process, analyze, and interpret data in order to extract knowledge and support decision-making. Now, if you've ever looked up what is data science, it's likely you have seen a million different definitions. Some say it's all about machine learning. Others say it's just statistics with better marketing. And honestly, that's a little sus. The truth is, data science sits at the intersection of multiple fields, which includes statistics, computer science, and domain expertise. Another thing you may ask is, what does data science have to do with AI and machine learning? How do these different areas overlap? Well, there's one thing that all three have in common. Why don't you take a wild guess what it is out of these three options? I'll wait. Okay. While you could argue all three options are valid, the answer that's truly relevant is data. Data is a big deal in AI, machine learning, and data science. In order for AI to make intelligent decisions, and for machine learning to learn proper predictions, we need data science to extract insights from that data, which leads to the next big question. What is data? Data is simply information. It's anything that can be recorded, measured, or observed. If something can be written down, stored, or tracked, it's data. Data can come in many forms. It can be numbers like sales totals, temperatures, prices, or your daily step count. It can be text like reviews, emails, tweets, or comments on a YouTube video. It can be images or audio like music files and voice recordings. It can even be videos like TikToks, security footage, or live streams. However, there is a big problem with raw data. Data by itself is a bit of a mess. It's just raw information sitting there without much context or meaning yet. On its own, it doesn't really tell us anything useful. To me, data is more like an encrypted storyteller. It's full of hidden patterns and insights that it wants to tell us, but the story isn't obvious at first glance. You have to do a bit of detective work to decode what it's actually trying to tell you. And that's exactly where data science comes in. Data science usually follows a series of steps. Not unlike the scientific method, the data science process looks something like this. This entire process is iterative and cyclical. You might be exploring data and realize you need to go back and collect more, or building a model and discover your data needs additional cleaning, or present findings and get feedback that sends you back to ask a completely different question. Let's go over each step. The first step of the process sounds deceptively simple, but can actually be the hardest. Asking the question. If you ask a vague question, you'll get a vague answer. For example, if you ask, "Why are sales down?" that might be a start, but it might need to be more specific, like, "Why did online sales drop among first-time customers in the last quarter?" The clearer and more specific the question, the more focused the analysis. This step often requires deep understanding of the business or problem space, not just a technical skill. This part of the data science process is often covered by business analysts. Once you get the question clear, the next step is collecting the data. This is pretty much exactly what it sounds like, but this step is bigger than most beginners expect. You first have to figure out what data actually matters for the question that you're trying to answer, which is why getting that question right in the first place is so important. For example, if your question is about why customers are leaving, you might need purchase history, login activity, customer support tickets, and maybe even demographic information. The key here is alignment. Every piece of data you collect should connect back to the question from step 1. This data can come from many different places. It might live in company databases, cloud storage systems, APIs, third-party platforms, website logs, mobile apps, IoT devices, or even manual surveys. Sometimes it's neatly structured in rows and columns, and other times it's completely unstructured, such as text reviews, images, or audio recordings. Another important part of collecting data is understanding how the data was generated. For instance, was it manually entered by humans, or was it automatically tracked by a system? These details matter because they affect how trustworthy and complete the data is. If users only fill out surveys when they're angry or dissatisfied, for example, your dataset might be biased. If tracking was turned on only halfway through the year, then your earlier data might be incomplete. There's also the issue of data accessibility and permissions. In real-world settings, you can't always access everything instantly. There are privacy rules, compliance regulations, and company policies, and navigating the bureaucratic processes to get approval can take weeks or even months. This is where a good amount of overlap comes in. Sometimes collecting data involves working closely with data engineers to build pipelines that automatically gather and update the information. So, after the arduous process of collecting the data, we move on to the next step, which is data cleaning. Arguably the least glamorous but most important part of the entire process. Here's the truth about data. It's a mess. A big mess. Raw data is not the perfect datasets you see in tutorials. It's inconsistent and full of surprises, and not the good kind. So what does dirty data look like? Typically, you'll encounter missing values, duplicates, inconsistencies, and outliers and errors. Missing values are everywhere. You'll see blank cells, stuff like this, and null values, and sometimes just random placeholders like 999 or unknown. The problem? Well, your analysis tools don't know what to do with missing data, and if you ignore it, your results can end up completely wrong. Then there's inconsistencies. Imagine you're analyzing customer locations and you see this, all in the same column. Technically, they mean the same thing, but to a computer, they're 4 different values. Inconsistent formatting like this can break everything. Duplicates are another headache. As you may expect, duplicates inflate your numbers incorrectly and skew your analysis. The same customer might appear twice because they signed up with 2 different emails. The same transaction might be logged multiple times due to a system glitch. Outliers and errors are pretty wild as well. You might see someone's age listed as 200 years old, a temperature reading of negative 999 degrees, or a price product of $0. Sometimes these are real edge cases, but usually they're just mistakes, typos, or placeholder values that never got updated. This is why cleaning data matters so much. If you put garbage data in, you'll get garbage out as a result. Your analysis will end up wrong, and so will your predictions. So how do you actually clean your data? To go into the details of actual data cleaning methods here would be outside the scope of this video, but typically the first step comes down to understanding the damage. For handling missing values, for instance, you may want to use the average value or the most common value. Dealing with duplicates could come down to just removing them. Standardization is huge as well, which is essentially just making sure everything is consistent. So yeah, data cleaning, as unglamorous and mind-numbing as it can be, is the difference between an analysis that works and an analysis that's completely off. Once your data is clean and organized, the next step is a bit more exciting: exploring your data. This is where you actually start to understand what you're working with. Think of data exploration as getting to know a new city. You don't just look at the map and call it quits. You walk around, check out different neighborhoods, notice patterns, and start to get a real feel for how things work. That's exactly what you're doing here, except with numbers, charts, and trends instead of streets and buildings. Data exploration is all about asking questions and looking for answers in the data itself. The goal here is to uncover patterns, trends, relationships, and anomalies that help you understand the story that data is trying to tell you. Exploring the data often involves working in layers. First, you want to get the big picture. How much data do you have? What variables are you working with? This means looking at summary statistics, things like the average, median, minimum, maximum, and standard deviation from numerical columns. And honestly, this stage, learning how to actually analyze data and recognize patterns, is where most people realize data science isn't just about coding, it's about thinking. One thing I've personally been using to build that kind of intuition is Brilliant.org. What I love about Brilliant is that you don't just watch lessons, you learn by actively solving problems step by step, complete with explanations, which forces you to really understand what's happening instead of just memorizing concepts. They have interactive courses across math, coding, AI, and of course, data science. One course I think pairs really well with what we're talking about here is Exploring Data Visually, which walks you through how to build a solid foundation, analyzing the data that I've been talking about, and reason through problems the same way that real analysis works. The lessons are created by educators from MIT, Harvard, and Stanford, and they're designed for anyone aged 10 to 110 years old who want to sharpen their thinking and problem-solving skills. If you want to try it out, you can get 30 days for free using my link or the QR code on screen, and you'll get 20% off the Brilliant Premium subscription, which gives you unlimited access to all of their courses. Now let's actually visualize what these patterns look like in real data. The next step is data visualization. The thing about us humans is that we are visual creatures. You could stare at a spreadsheet of 10,000 rows trying to find patterns in raw numbers, but I think the proper reaction to that is best shown by my friend Leon Kennedy.
No thanks, bro.
Fortunately, we don't actually have to analyze data this way. Thanks to tools and languages like Python, there are plenty of ways to visualize our data. So what do? Well, we make graphs, and lots of them. Histograms show you the distribution of a single variable, such as how customer ages are spread out. Bar charts compare categories like sales across different regions. Line charts reveal trends over time, like monthly revenue growth. And you also have scatter plots, which show relationships between two variables, like whether ad spend correlates with sales. The goal here isn't to make pretty pictures, although that is a bonus, but to see the data in ways that numbers alone cannot show you. For example, a spike in a line chart might reveal a seasonal trend. A cluster in a scatter plot might suggest a hidden relationship. An outlier in a histogram might point to a data quality issue that you missed. The next step is to model the data. It's time to make an important decision. Do you actually need to build a model? Something that gets overlooked is that not every single data science project necessarily needs a model. A well-made chart or a clear comparison from the previous step might be all you need to solve the problem. But if your goal requires predicting or classifying things, or uncovering complex patterns that are not obvious from exploration alone, then that's when you need to build a model. This is where machine learning comes into play. A model is basically a mathematical system that learns patterns from past data and applies them to make predictions about new data. The process of building your model is a complete process on its own, covered in more detail in my machine learning video. Be sure to check it out to learn more about how models work, and comment down below if there's any specific type of model you want me to cover in the future. Lastly, we need to communicate the results. Data science isn't just analysis, it's storytelling with evidence, and the goal is to provide clarity from an ocean of complexity. It's important to know your audience. Technical teams want methodology and metrics, while business stakeholders want to know what all your discoveries mean and what actions to take. This is the step where all your hard work either pays off or gets ignored, because data science is only valuable if it leads to better decisions. And that happens only when people understand what you found and why it matters. Now, you may have noticed that there seems to be a lot of overlap between machine learning and data science. And well, That's because there is. In fact, machine learning is basically a subset of data science. Think of data science as the whole pizza, and machine learning is one really important slice. Data science is the entire process. It uses statistics, programming, domain knowledge, and yes, sometimes machine learning to extract insights from the data. Machine learning is specifically about building algorithms that learn patterns from the data and make predictions without being explicitly programmed, such as the prediction and classification tasks I mentioned earlier. Data science is the job, and machine learning is a tool, like carpentry versus a power drill. You'll probably learn machine learning if you go deep into data science, since most data science roles expect at least basic machine learning knowledge. But you won't really need to build GPT-5 from scratch. So there you have it, the data science process from start to finish. Remember, it's not perfectly linear. It's iterative and cyclical. You'll often loop back, rethink things, pivot based on what you learn, and sometimes realize halfway through that you need to start over with a different approach. That's not failure, that's how data science works. The process is also context dependent and collaborative. You're constantly working with stakeholders, engineers, and domain experts, adapting to feedback and changing direction when needed. If you're interested in diving deeper into machine learning specifically, I've created a free machine learning ebook designed to simplify the learning process and break down complex concepts into digestible, practical lessons. Just click the link in the description to sign up and get your copy. Whether you're just starting out or looking to strengthen your foundation, it's a great resource to have in your toolkit. Thank you guys for watching, and I'll see you in the next video.